Hello everyone. In this video we're going to go over some slightly more complicated examples using inequalities. Try our first inequality. We'll go over it now. 4 times the absolute value of x minus 3 is less than 17. Remember, the absolute value of x is the distance of x on the number line from 0, which means minus x and x have the same absolute value. So, the absolute value of, say, minus 5 is equal to the absolute value of 5 is equal to 5. Pretty simple. So, first, we can add 3 to both sides, which doesn't change our inequality sign. And then we can divide by 4. And since 4 is positive, that also doesn't change our inequality sign. And now we have the absolute value of x is less than 5. So, if we have an xy graph, and this is our x is equal to 5 line, and this is our x is equal to negative 5 line, and remember, when considering absolute value, you have to think about both the positive and negative sides. If the absolute value of x is less than negative 5, x could be 4, 3, 1.5, 0, negative 1, for example. So, x could be anything between these two lines. This entire region is our solution. Any point in this region satisfies our inequality. For example, look at the point 0, 0. X is 0. The absolute value of 0 is 0. 0 is less than 5. Satisfied. There are actually an infinite number of solutions inside this region. Because remember, we can take decimal solutions like negative 1.1 comma negative 1.1. Let's try another problem. Here we have 2 inequalities. We deal with these just like we deal with systems of equations. We graph both of them, and then we find the region which satisfies both the inequalities. So let's graph the first one. X is less than or equal to 2. If this is our x is equal to 2 line, then our answer would be anything to the left. For all values here, for all points in this region, the x value is less than or equal to 2. So let's include our x is equal to 2 line. Our second equation, x minus y is greater than 1. If we reorder this a bit, x minus 1 is greater than y. So that's a y-intercept of minus 1. 0 minus 1. And we could graph our line like approximately like this, because the slope is 1. And the answer to our second inequality would be all points xy satisfying x minus y is greater than or equal to greater than 1. So to see which side to choose, let's choose the point 0, 0. 0 minus 0 is greater than 1. That is false. So we must choose the right side instead. Because 0, 0 is on the left side of the line, and 0, 0 does not satisfy our inequality. Now, The answer to this system is the region on the graph which satisfies both the inequalities. So for us, that would be the region where the green and gray intersect, or this region over here. Make sense? The gray region is the area which satisfied our first equation. The green region is the area which satisfied our inequality, first inequality and second inequality. And the solution to the system would be the area that satisfies both inequalities. So that doesn't equal our line here, but it equals our line here. To see if this works, let's take the point 0, comma minus 2, which should be somewhere there, and see if it satisfies both. 0, comma minus 2. So for the first equation, we would have 0 is less than or equal to 2. That's correct. And for the second equation, we have 0 minus 2 should be greater than 1. 2 is greater than 1. And that's also correct. Cool.